Hello tech lovers! Welcome to the first lesson of the course Digital Wireless Communications from 2G, 3G and 4G LTE. Here, we begin by reviewing the radio transmission techniques from 2G and 3G communication systems. We are going to cover the principles of modulation, signal reception and channel estimation. But first, don't forget to hit the subscribe button, activate the bell to be notified when I upload a new video, like, share, and leave your opinion in the comments below. Join our group on Facebook, link is in the description. This figure on the right shows the most important components of a wireless transmission system. The transmitter accepts a stream of bits from the application software, and then it encodes these bits onto a radio wave, known as carrier, by adjusting parameters of the wave such as its amplitude or phase. The transmitter usually processes the information in two stages. In the first stage, a modulator accepts the incoming bits and computes symbols that represent the amplitude and phase of the outgoing wave. Then it passes this to the analog transmitter, which generates the radio waves itself. The modulation scheme used in figure is known as quadrature phase shift keying, QPSK. A QPSK modulator takes the incoming bits two at a time and transmits them using a radio wave that can have four different states. These have phases of 45 degrees, 135 degrees, 225 degrees, and 315 degrees. As we can see in the figure, which correspond to bit combinations of 00, 10, 11, and 01, respectively, of course. We can represent the four states of QPSK using the constellation diagram shown in the figure. In this diagram, the distance of each state from the origin represents the amplitude of the transmitted wave, while the angle represents its phase. Usually, it is more convenient to represent each symbol using two other numbers, which are known as the in-phase and quadrature, where A is the amplitude of the transmitted wave and phi the phase. Mathematicians will recognize the in-phase and quadrature components as the real and imaginary parts of a complex number. LTE uses four modulation schemes all together. Talking about LTE, we have another course of LTE architecture, link in the description or here in this card. Binary phase shift keying, BPSK, sends bits one at a time, using two states that can be interpreted as a starting phase of 0 degrees and 180 degrees, or as signal amplitudes of 1 or -1. LTE uses the scheme of a limited number of control streams, but does not use it for normal data transmission. 16 quadrature amplitude modulation, or 16 QAM, sends bits 4 at a time, using 16 states that have different amplitude and phases. Similarly, 64 QAM sends bits 6 at a time using 64 different states. So it has a data rate 6 times greater than the BPSK. In a wireless communication system, the signal spreads out as it travels from the transmitter to the receiver. So the receiver power is less than the transmitted power. By itself, propagation loss will not be a problem. However, the received signal is also distorted by terminals, noise, and by interference from the other transmitters. These effects mean that the receiver cannot make a completely accurate estimate of the transmitted amplitude and phase. The receiver deals with this issue as follows. The symbol estimation stage extracts the amplitude and phase of the incoming signal in the form of continuously varying real numbers. The demodulation then uses this information to estimate the received bits, which can take the form of hard decisions in which the bits are either 1 or 0, or soft decisions that include some measure of confidence. As shown in the figure, a typical demodulator will first estimate the soft decisions and then convert this to hard decisions later on. If the noise and interference are large enough, then a bit of 1 can be wrongly interpreted as a bit of 0 and so on, leading to bit errors in the receiver. The error rate depends on the signal to interference plus noise ratio at the receiver. In a fast modulation scheme such as 64 QAM, the signal can be transmitted in many different ways, using states in the constellation diagram that are packed closely together. As a result, 64 QAM is vulnerable to errors and can only be used if the SINR is high. In contrast, QPSK only has a few states, so is less vulnerable to errors and can be successfully used at a low SINR. LTE exploits this by switching dynamically between different modulation schemes. It uses 64 QAM at a high SINR to give a high data rate but falls back to 16 QAM or QPSK at a lower SINR to introduce the number of errors. To reduce the number of errors, there is one remaining problem with the receiver from the figure. The phase of the received signal depends not only on the phase of the transmitted signal, but also on the receiver's extract position. If the receiver moves through a half wavelength of the carrier signal, then the phase of the received signal changes by 180 degrees. When using QPSK, this phase change turns and completely destroys the received information. To deal with this problem, the transmitter inserts occasional reference symbols into the data stream which have a predefined amplitude and phase. In the receiver, a channel estimation function measures the reference symbols, compares them with the ones transmitted and estimates the phase shift that the air interface introduced. It can then move this phase shift from the information symbol and can recover the information bits. The resulting receiver architecture is shown in this figure. The incoming signal arrives with a different phase angle from the shown earlier. However, the channel estimator detects this phase shift, which allows the receiver to restruct the transmitted bits in the same way as before. The phase shift does not change much from one symbol to the next, so the reference symbols only need to take up a small part of the transmitted data stream. The resulting overhead in LTE is about 10%. Yeah. Hello tech lovers, thanks for watching and don't forget to like and share the video. I am launching one lesson per week, so it is important that you subscribe and activate the bell to be notified when I upload a new video. Stay home, wash your hands and take care.